there could be trillions of planets in our Milky Way galaxy alone. Are any of these alien worlds alive? These are some of the most challenging questions science has ever faced. Once begun on a planet, life probably needs a relatively smaller star to help it evolve, one that is stable and not stormy. A star like our Sun. We are living proof of what's possible. Our parent star is in the middle of its 10 billion year life. Clearly time enough for the happy accidents of evolution to build a world like ours. It is easier to detect Earth-mass planets that may be tugging on these small stars because the telltale wobbles in their stars' positions on the sky are proportionally greater.
There is an Earth-sized planet orbiting Ross 128. And it resides in the habitable zone where life, sustained by liquid water, is possible. Now, wielding sensitive new instruments, planet hunters are suddenly finding thousands of new worlds all over the sky. But have any of them sprung to life? Or are we on Earth, lone orphans of the universe? In 2007, the HARPS team at La Silla picked up the first evidence of a planet in the habitable zone of its star, a red dwarf named Gliese 581, 6 times more massive than Earth, and rotating so slowly its day is perhaps 70 of our days long. Gliese 581d may globally warm itself with greenhouse gases. So it could be an ocean planet, the first one spotted. If so, it probably began as an ice giant further out in the system. Kepler-22b was the first exoplanet that mission scientists found in the temperate zone of a star like ours. That star is just slightly smaller than ours. But the planet is bigger, about 2 times Earth's diameter. The transit method isn't very good at pinning down planetary masses, so we don't yet know how it weighs in compared to Earth. Researchers speculate it may be a water world, a deep global ocean clinging to a massive rocky core. 22 light-years out in another direction, Gliese 667cc swings round a cool red M dwarf in just 28 days. At that distance, the star looks 3 times wider than our Sun does to us. And you'd see 2 other prominent lights in that sky. The star has 2 nearby sisters. The planet is massive, maybe 5 times Earth's mass. Standing on its surface, if it has one, you'd weigh 1.5 times what you do at home. But it's possible you'd feel right at home in other ways. Gliese 667cc, could be habitable. .10% larger than our planet, Kepler 186f lives just within the outer edge of its star's Goldilocks zone. That star is a red dwarf about 500 light-years distance. 4 larger, hot, and presumably lifeless planets ride closer in to the dwarf. 186f is roughly Earth-sized, perhaps just 11% larger. But it's probably colder than Mars. In 2013, a pair of planets surfaced in the Kepler data. 62e and 62f circle their cool star in orbits where plenty of water could flow. The inner one is likely a totally wet world. The outer, a super-Earth, 1.5 times our size, could be cooler and drier. Now, imagine a cloudy world where you weigh at least twice what you do on Earth. Kepler 452b, sometimes called Earth's cousin, is probably rocky like us and 1.6 times our size, but it may be up to 5 times more massive. 1,400 light-years from us, it orbits a G-type star very much like our Sun. It's 20% brighter, but the planet rides a bit further out from its star. The Kepler 452 system is 1.5 billion years older than ours. Evolution has had more time to work. It was long thought that the most likely place for life would be an Earth-like planet circling a Sun-like star. But in 2017, a system full of surprises came to light. A tiny star not much bigger than Jupiter, hosting 7 rocky planets, all about the same size and mass as Earth. TRAPPIST-1F is likely the best positioned for life. The red sun in its sky would look larger than ours does to us, but less than 1/100th as bright. It could be warm there, though. Like tussling siblings, 7 worlds so near to one another probably jostle one another's orbits. They try to keep in resonance. Their orbital periods pulled into whole number relationships. But those gravitational tugs could power up tides, keeping these worlds warm, mixing the chemistries that lead to life. The TRAPPIST-1 system has had a long time to brew. The little star could be more than twice as old as our Sun, and it could live at least 10 times longer. Like Ross 128, TRAPPIST-1 is a quiet dwarf. Its ultraviolet radiation wouldn't strip the atmospheres of the planets in its habitable zone for perhaps 15 billion years. The search for nearby worlds that may be like our own is accelerating. Large arrays of millimeter and submillimeter wavelength dish antennas, like this one in the high, cold Atacama Desert, are revealing how baby planets grow within the dust disks of young stars. The giant Magellan Telescope at La Serena, Chile, with a segmented primary mirror 24.5 meters across, and the extremely large telescope, also in Chile, but at Cerro Amazones, with its nearly 40-meter-wide aperture and laser-guided adaptive optics, will try to take direct images of exoplanets, at least 5 times sharper than the Hubble Space Telescope.